Hello everyone. In this video, let me solve GATE 2020 Engineering Mathematics questions related to the concept limit, continuity and differentiability. It's from calculus main topic. In GATE exam, all engineering branches has this topic. So this video is very useful for all branches students. The necessary definitions and concepts for solving these problems are explained in the concept video. I gave the concept video link in the description box. Keep watch if you need to. Now let's move on to the problems. The first problem is the value of limit extends to infinity. One rational function is given is dash. You have to find the value of limit this function. This question is from civil department. It has 1 mark. Here the limit is extends to infinity. So I substitute the limit. I got infinity by infinity, that is indeterminate form. So in this case, at limit extends to infinity case, first we have to do the highest power of x. Take the outside in the numerator and denominator. Here the highest power of x in the numerator is x square. So I take outside x square in the numerator. I got 1 minus 5 by x plus 4 by x square. Similarly, you have to take highest power of x in the denominator. This is also x square. So finally I got 4 plus 2 by x. Here x square cancel. In that place I use another one result. That is, if r greater than 0 is a rational number, then limit extends to infinity 1 by x power r equal to 0. By using that result, you can say limit extends to infinity 5 by x is 0, because limit extends to infinity 1 by x power 1. This is 1 by x power 1. So in this case 0, and this is also 0, 1 by x square. So that place 0, that place 0. So finally I got the limit extends to infinity, that value is 1. Numerator is 1 and denominator is 4. So the final answer is 1 by 4. Answer is option B. Now second problem. A function f is as follows. One function f of x is given, that is two condition, x less than 1, f of x is 15, and x greater than or equal to 1, f of x is cx. The function f is continuous function when c is equal to what? We have to find the value of constant c. This question is from BT department. It has 1 mark. Given function f is continuous in the two interval, that is x less than 1 and x greater than or equal to 1. I take f is continuous at x equal to 1. F is continuous at x equal to 1. Suppose f is continuous at x equal to 1. In this case, f is continuous at all the values. So f is continuous at x equal to 1. Left hand limit at x equal to 1 and right hand limit at x equal to 1. These two are equal to f of 1. Okay. So I have to find limit extends to 1 plus, that is right hand limit, this is plus, equal to 1 plus means x greater than 1 values, cx, f of x equal to limit extends to 1 plus cx, this is equal to c. Here by using the function f of 1 equal to x equal to 1 case, we get cx only. So this is also c. Put x equal to 1, we can get c. And next I find left hand limit of at x equal to 1. Left hand limit of f of x at x equal to 1. That means x less than 1 case. In this case, limit extends to 1, f of x is 15. So this is 15. Here the given function is continuous function. So left hand limit and right hand limit equal to f of 1. That means limit extends to 1 plus f of x equal to limit extends to 1 minus f of x equal to f of 1. Here right hand limit is c, f of 1 also c, this is 15, left hand limit is 15, this is c. So the final answer c is 15. Answer is 15. Now that question, let L equal to limit extends to pi by 2 sin x power tan x, the value of L. Find the value of limit. We have to put L. Okay, we have to find the value of L. This question is from TF department. It has 2 mark. First, I substitute the value of pi by 2 in x. We can get, this is the sin pi by 2 is 1, tan pi by 2 is infinity. This is the indeterminate form. Indeterminate form. In this case of indeterminate form, you have to take the function. The function is y equal to sin x power tan x. The next step is taking log on both sides. Log of y equal to log of sin x power tan x. Next, I use one logarithmic rule, that is tan x log of sin x. This side log y. Next, I take limit extends to pi by 2 of log y. So limit extends to pi by 2. Log y is tan x log of sin x. Here I can write tan x is 1 by cot x. So in the next step I write log, numerator value is log of sin x divided by 1, tan x is 1 by cot x. So in the denominator I write cot x. Now you substitute the value of pi by 2 in x, we can get log pi by 2, sorry, log of sin x. Next, cot x. Sin pi by 2 is 1. So log 1 is 0, cot pi by 2 is 0. So you have to get 0 by 0. This is the indeterminate form. In that place, I use L'Hospital rule. That is, L'Hospital rule says limit of quotient is equal to the limit of derivative of quotient. That means limit extends to pi by 2 equal to the differentiation of log sin x is 1 by sin x, and sin x differentiation is cos x, and the differentiation of denominator is cot x, denominator differentiation is cosecant square x minus cosecant square x. Now I substitute the value of pi by 2 in x. We can get sin pi by 2 is 1, cos pi by 2 is 0. So in the numerator I got 0, and cosec square pi by 2 is 1. Here minus 1. But the numerator is 0, so whole value is 0. Finally, I got limit extends to pi by 2 log y equal to 0. So limit extends to pi by 2 y. Y is the given function, sin x power tan x. Y equal to, taking e power, we can get the answer. E power 0, this is equal to 1. So the final answer is 1. That is option B. Final answer is 1. Option B is the correct answer. The fourth problem is the value of limit extends to infinity root of 9x square plus 2020 divided by x plus 7 is what? This question is from civil department. It has 1 mark. Here the limit is limit x at infinity. So substitute the value of x at infinity, we can get infinity by infinity form, indeterminate form, indeterminate form. In this case, limit extends to infinity, you have to take highest power of x outside in the numerator and the highest power of x in the outside in the denominator also. So in this case, square root of x square is highest power. So in the square root of x square, 9 plus 2020 by x square divided by, in the denominator the highest power is x only. So take outside x, we can get 1 plus 7 by x. Square root of x square is x. So this x and this x is cancelled. Next, limit extends to infinity. X square root of 9 plus 2020 by x square divided by x into 1 plus 7 by x. X cancel, and limit extends to infinity. 1 by x power r equal to 0 if r greater than 0. So this value is 0. Limit extends to infinity, 2020 by x square is 0 and 7 by x also 0. So x cancel. Finally, I got root 9 by 1, that is 3. The final answer is 3. Answer is option C. Now the fifth problem. The value of limit x tends to 1, some function is given. We have to find the value of limit at x tends to 1. This question is from mechanical department. It has 1 mark. First I substitute the limit x equal to 1, x tends to 1. That means substitute the value of x in 1. We can get 1 minus e power c, 1 minus 1 is 0. So we can get e power 0, 1 minus 1, 0. And I substitute here 1 minus e power 0 divided by 1 minus x into 1 minus x also 1 into e power 1 minus 1, 0, e power 0. So e power 0, 1, 1 minus 1 divided by 1 minus 1, 0 by 0. This is indeterminate form. So here I use L'Hospital rule, that is limit x tends to 1. L'Hospital rule says the quotient, limit of the quotient is the derivative of the quotient is equal. These two are equal. That is, the derivative of numerator is 1, derivation is 0, and e power minus c 1 minus x is minus e power minus c 1 minus x into c, because minus x value is minus 1, minus of minus c is plus c, divided by, in the denominator, differentiation of denominator is, derivative of denominator is x into e power minus. So minus is common and uv method, multiplication, x u dv, dv is e power minus c 1 minus x into c plus v du, v is e power minus c 1 minus x and du is 1. So in this case denominator is this one. Next, here I substitute the value of x equal to 1. Next I substitute the limit. So in this case I got 1 minus 1, x is 1, so 1 minus 1 is 0, e power 0 is 1. So finally I got in the numerator minus c. Similarly here e power 0, this is 1, this is also 1, so x into x also 1, c plus 1, minus of c plus 1, minus minus cancel, c by c plus 1 is the final answer. C by c plus 1. So the final answer is option C. Answer is option C. The next problem is limit x tends to 0. Some function is given. We have to find the value of limit. This question is from AG department. It has 1 mark. First I substitute the value of x at 0. We can get e power 0 minus e power 0, that is 1 minus 1 divided by, this is 0, 0 minus sine 0 is 0. So finally I got 0 by 0. This is indeterminate form. So I use L'Hospital rule, that is limit x tends to 0. The derivative of numerator is e power x is e power x and e power minus x is minus e power x. So we got plus e power minus x and minus 2 divided by 1 minus sin x, differentiation is cos x. In this case, you substitute the limit, we can get 1 plus 1, 2 minus 2, 0 by 1 minus cos 0, 1. So 1 minus 1, 0. This is also indeterminate form. So again I use L'Hospital rule, e power x minus e power minus x, differentiation of numerator, and 1 plus, 0, this is 0, 1 differentiation is 0, 0 plus sin x, cos x differentiation is minus sin x, so plus sin x. Then you have to put the limit e power 0 minus e power 0, that is 1 minus 1, 0 divided by sin 0, 0, so 0 by 0 form. Again I use in the L'Hospital rule, e power x plus e power minus x divided by sin x, differentiation is cos x. In this case we got e power 0, 1 plus e power 0 also 1 divided by cos 0, 1. So 2 by 1, the final answer is 2. So the final answer is 2. These are the GATE 2020 engineering mathematics questions related to the concept limit, continuity and differentiability. If you have any doubt, then you can ask in the comment section. Let me try to clarify your doubts. Thank you. See you in the next video. If you like this video, please like, share and subscribe my channel to encourage me. Thank you.